Stars are born, live out their lifespans, and die. The life history of a star is marked by an opposition of two kinds of pressure. One is the pressure created by the energy in the core of the star, pushing the surface outward. The other is the crushing force of gravity pulling the star's surface inward. When these are balanced, a star becomes stable and shines steadily. As hydrogen fuel is depleted, the release of energy is insufficient to withstand the gravitational pressure, and the core collapses. But compression by gravity raises the temperature in the core, and helium ash rekindles the nuclear fires. Vast amounts of energy are released and lift the outer zones against the force of gravity. The star is now a red giant. In the final stage of its evolution, it is the mass of a star that determines its fate. The Sun, the medium-sized star, remains stable for approximately 10 billion years. Then it will expand to 400 times its present diameter. As it expands, it will engulf the inner planets, Mercury, Venus, Earth, and Mars, and create a nebula extending past the outer planets. After millions of years, its reserves of nuclear fuel will be exhausted, its outer layers will have dissipated, and only a white dwarf star remains, no larger than the Earth. Slowly cooling to zero temperature, it will end its life as a black stellar corpse. When a star more massive than the Sun reaches the red giant stage, the collapse of its core raises its temperature billions of degrees and triggers a spectacular detonation. A supernova explosion. At the center of the explosion, a residue of the star is crushed by gravity to a neutron core, only a few miles across, but so dense that 10 billion tons of its matter would fill only a tablespoon. It spins rapidly, generating radio signals in its strong magnetic field. And a radiation beam sweeping past the Earth is observed as a pulse. The star is known as a pulsar. An even stranger end is predicted for very massive stars. According to the laws of gravity as presently understood, nothing can stop its collapse. The star disappears from our universe, leaving a black hole in space. Its presence can be deduced only by its influence on a visible companion star, distorted out of shape by the black hole's gravitational attraction. Gas, pulled off the visible star, circulates about the black hole, and in the dizzying plunge, it emits X-rays which can be detected in space. No light or matter can ever leave the intense gravitational field of this cosmic abyss. The physical laws that govern the conditions within this bizarre object are totally unknown to us.